In this lesson, we will practice simplifying expressions with exponents, some of which will have negative values. Anything to the 0 power is equal to 1. So, what's out? Number 2. Now, so wow, there's a few different things going on here. Let's see. Remember that you have to deal with the exponent before you do any multiplication. So this negative sign out here, it's like you're multiplying by -1. So you definitely cannot do negative times a negative is a positive and cancel these out. That's not happening. Instead, we have to do this first and just leave that negative sign sitting out there for a little while. It might yet go away, but not now. So, looking at just the yellow part, a negative power means you need to drop that thing down to the denominator because it is on the wrong side of the invisible fraction line. Okay, so here's my invisible fraction line. This is on the wrong side of it, so it's going to drop down. Okay, that negative, I'm going to leave it just floating there for a minute. This -15 is going to drop down here like this. And that would be like -15 to the 1 power. But don't you feel silly? We don't put the 1 power on things. So there we go. We have a -15 in the bottom. Now, in the top, of course, we're going to use a 1, sort of like a placeholder, I guess you could say. Or you could think of it as being a -1 that was there the whole time. And we move this down, and just the -1 is the only thing that's left. And now we can deal with these signs. So yes, a negative divided by a negative is a positive. So in the end, it will be 1/15. Okay, you will not have access to your TI-30 XS Multiview or any other such calculator. So you can use a 4-function calculator if you have forgotten how to add, subtract, multiply, or divide. But you will not be able to, for instance, just type this whole thing in as negative quantity, -15 quantity to the -1 power and just go, look, oh look, 1/15. You will not be able to do that. So, you know, plan accordingly. Number 3. Okay, so here we have 2 times 3 and then squared. So 2 times 3 is 6. And then 6 squared is 36. Number 4. Anything to the 0 power is 1. So, what's out? Okay. When you have a fraction to a power, you're just going to do that power to each one of these things. Alright, so in your mind, you're thinking 3 squared over 5 squared. So that's going to be 9 over 25. Alright, now when you have a negative power on a fraction, you're thinking this. Yeah, so if you have a over b to the -5 power, for example, think reciprocal. This is going to be the same thing as b over a to the +5 power. And then, of course, you'll go ahead and do the powers and have b to the 5th power over a to the 5th power. So anytime you have a fraction raised to a negative power, the quickest thing to do is to do the reciprocal and make it a positive power. Okay, so that's what we will do here. However, the reciprocal of 1/5, okay, if I have 1/5 to the -5 power, the reciprocal of 1 over 5 is 5 over 1. right? But isn't 5 over 1 just 5? So it's really just 5 to the 5th power. And anything that's bigger than cubed, you can just leave it. Okay, so this is going to be 5 to the 5th power. And you can just leave it like that. Especially since you don't have a TI-30 XS multi-view. Alright, simplify each expression assuming that no variable equals 0. Write your answer with positive exponents. Okay, well, if you have a variable times a variable and the bases are the same, you can start off by adding these exponents. You know what I mean? Just like if I had n to the 2nd power times n to the 3rd power, what would that be? Hopefully you were saying or thinking n to the 5th power. So with that in mind, add these exponents. So that's going to be d to the 3 plus negative 4 is negative 1. Okay, but you can't stop there. You got to go 1. You have to drop this down to the denominator. So that'll be 1 over d. Okay, negative exponent. Got to drop it down. Number 8. Okay, so first let's collect things. If you need to, think of this as w to the 1 power z to the 1 power z. Alright, if you're clever, you don't need that. But, you know, some of us are not clever. And if you're like me, sometimes you're more clever than other times. Anyway, w to the 3rd power times w, that will be w to the 4th power. You know, I put the little 1 for a minute because you can think of it as doing 3 plus 1 if you need to. But, you know, w to the 3rd power times w, that's 4 w's. Now, but with the y's though, this will be y squared because I am adding, alright, once I'm dealing with negative and such. 4 plus negative 2 is 2. And now with the z's, okay, this will be z squared. So actually that's it. Alright, there are no more negative exponents to drop down or anything. So that's the answer to number 8. So number 9. I can do a similar thing here. Negative 11 plus 3. So at first I get k to the negative 8th power. But then, because of the negative power, I have to write 1 over k to the 8th. So that's cool. That's cool. Wow, this is really simple. A power raised to a power you multiply. So that's just x to the 14th power. What could be easier? Okay. Alright, here's starting to get a little bit uglier. There are multiple things that you can do. If I were you, I would work from the inside out. So I would start by simplifying what is inside of this situation. So this is a little ugly. I'm going to recopy it. 1 over, I'm going to do it on the black screen. So what we have is 1 over x to the, I think it was a negative 7, and then that is to the negative 5th power. Did I have that right? Yes. Okay, so if you do the inner part first, look what is happening. Because this has a negative power, it is going to move to the other side of the fraction. So it's going to move up. Okay, so just recopying the outer shell here. Alright, I have outer shell, negative 5. I haven't changed any of that yet. But for a minute, I had 1 over. But then here I came along and moved this x to the negative 7 power up. And so it became x to the positive 7 power. Now that it's up in the numerator and there's nothing in the denominator, it becomes clear that I didn't really need the fraction anymore. So I just have this. So now the easiest thing to do from this point is to remember the rule about what you do when you have a power raised to a power. Hopefully you remember that you multiply those. Okay, so that is going to be x to the negative 35 power, alright, just multiplied. But then of course when you have a negative power, that's just simply going to drop down to the denominator. So I'm going to have 1 over x to the 35th power. So that's the final answer. Okay, that took a little bit of doing. Okay, so here I have z to the 15th. Okay, I'm just going to recopy it right here. It's a little fuzzy. So this is z to the 15th power over z to the negative 2 power. Okay. Now, this has a negative 2 power, so anything with a negative power is going to move to the other side of the fraction and become positive. So, the z to the 15th power, that's not moving. That's staying right where it is. I'm just moving this up. So the green z is going to come up to the numerator and become z squared, positive. I really don't need the fraction anymore because there's nothing in the denominator. So I just have this. Now I'm ready for my final answer. Of course I will add these, so that's going to be z to the 17th power. Wow. Okay, that's how that works. Number 13. Okay, these are quite fuzzy, so I feel I shall recopy. So what we have is y to the 14th power, and we have z to the 5th power over y to the 9th power, z to the 4th power. Okay, let's just treat these separately. So let's do the y's first. So if I do the y's, okay, you can think of it as subtracting. I really think of it as canceling, right? 14 minus 9 is 5. Okay, so anyway, these 9 y's are going to cancel out 9 of these y's and leave 5 behind. So that's why I'm going to have y to the 5th power in the numerator. Similarly, these 4 z's are going to cancel out 4 of these z's, and that's going to leave just z in the numerator. And nothing's in the denominator, so that's my answer. Y to the 5th power z. Wow. Okay. Okay, this is weird looking. Let's go ahead and simplify the stuff that's on the inside first. So, doing what I just suggested. I have negative 2 times 3 times 6. Negative 2 times 3 is negative 6. Okay, and then I've got times 6, so that's going to be negative 36 so far. And then the variables a, b, c. Okay. Now I'm supposed to do the 4th power on all of these things. Weird. I'm just trying to decide. Yeah, I'm just going to go ahead. So what I have is I've got this negative 36, and I have to raise that to the 4th power. And then I'm going to have a to the 4th power, and b to the 4th power, and c to the 4th power. There are many different ways I could have expressed this. So normally we do the inner part first. So I'm getting this negative 36. So when you raise a negative number to an even power, the negative is going to go away. So that at least is going to give us positive 36 to the 4th power, and then a to the 4th power, b to the 4th power, c to the 4th power. Okay, that's how I would express it. And we decided that anything bigger than 3rd power, we could just leave it, especially since we don't have a calculator. Alright, there are other ways you could have done it, but this is what I'm thinking. Alright, you could have done something with the 6's, and you could have written this as like 6 squared. Okay, and then you would have had, to the 4th power, whatever. There are other ways, but that's one way. Okay, number 15. Alright. Again, I'm going to recopy it first. So what we have here is a to the negative 2 power. You know what? I'm going to recopy it, but I'm going to color code it. Anything in green is on the wrong side of the fraction. So, yeah. So here's my fraction and stuff. Alright, maybe I should use this green. So what I have here is a to the negative 2 power, and I have b to the negative 3 power. Now, both of these are on the wrong side of the fraction, so that tells me that the a needs to come down and the b needs to go up. So I would do that first, before you do this part on the outside. So for right now, I would keep the shell the same. Okay, keep the shell the same. So if I make these reversals as discussed, then the b will come up, so I'll have b to the 3rd power in the numerator. The a comes down, so I'll have a squared in the denominator. Okay? Now, like I said before, when you have a negative power on a fraction, the easiest thing to do is to take the reciprocal and make it positive. Alright, it's not the only way, but it's my favorite way. So that's what I would do right now. So this is going to then become, I think I'll keep the colors the same for now. So if I want to take this shell and make it a positive 2, then I have to do the reciprocal in here. So that's going to make this become a squared in the top, and you know what? This is the long way. This is the long way, y'all. So I've got this. I'm going to go back and do it. I feel silly now. Whatever. This is the long way. I'll go back and do it the short way. By God. So now that I have taken care of all these negatives, now I can go ahead and square everything, which means multiply when you're dealing with exponents. So this is going to make, in the end, a to the 4th power over b to the 6th power. So that is the final answer. Now let's look back and see what the quicker way would have been. And you'll see why I feel so silly. If I looked ahead just a little bit, and I remembered it there at the end when I multiplied. When you have a power raised to a power, you multiply. So if I were to do that right now at the beginning, first step, look what happens. I have negative 2 times negative 2, that's 4. I'd have negative 3 times negative 2, That's 6. I would immediately get this as the answer without the rigmarole. Whoa, I really messed that up, didn't I? So many problems. Okay, so this is the better way. 1 step is better than 4 steps. Okay, let's just pretend that didn't happen. Anyway, so on number 16, can you read it? This says w to the 6th power over k, and it's being raised to the 3rd power. There's not much to this. Power to a power, you multiply it. So this will be w to the 18th power over k to the 3rd power. Just, you know, that's it. Not much to it. Okay, this looks like a little bit more happening. Okay, let's just break this down into itty-bitty pieces. First of all, let me just recopy this. Alright, so here's the problem. I've just recopied it so it's a little easier to read. If I were you, I would always work from the inside out. If there's anything you can do on the inside of a problem, do it. And then work your way out, you know, unless you can look ahead and see a quicker way like the last problem. Embarrassing. Anyway, so I would really start with this little part right here. Okay. Oh, I thought I was going to capture that. I'll try one more time. Okay, anyway, that's what I'm going to start with. Maybe I'll fake it out with some highlighter. Make it be green all of a sudden. Okay, I'm going to do that green part first. So, a power raised to a power, you multiply those. So, I'm going to keep the shell for now. So, here's my shell. My -1 power. I haven't done anything with this x to the 5th power yet. Okay, but power to a power you multiply, so this will be x to the 6th power and y to the 6th power. Alright, now I would simplify these x's, right? So these x's are going to cancel out 5 of these x's, and that's just going to leave 1 x in the numerator. Alright, you understand because you're very, very smart. Tell by the look in your eyes, you have a sharpness about you that is impossible to deny. So that's going to leave us with x, and then okay, that y to the 6th power is just still sitting there unchanged. Okay, there's nothing in the denominator, so we don't really need the fraction mode anymore. So now we've got this. So because there's no more fraction, we won't really be thinking of this as a reciprocal. Alright, we'll just be doing a power raised to a power. Okay, so basically you multiply. Alright, so that's why on the next move we are going to have x to the -1 power and y to the -6 power. Alright, you can kind of think of this as x to the 1 power if it makes you feel better. And I'm just multiplying by both of these. Okay, but now both of these have negative powers, so you know that they're going to have to drop to the denominator. So that's why it's going to be 1 over x y to the 6th power. So that will be my final answer. Brilliant. And this is the last problem, which is even more brilliant. Alright, so here I've just recopied the problem. So notice we do have a negative power, this m to the -2 power. So that means that this is going to have to drop down to the denominator. Everything in yellow is going to stay just where it is. So I'm just going to recopy it all. Okay, everything in yellow stays put. Alright, including the -4. So I'm still going to have my 2, and I'm going to have my m. I'm going to leave a little space for this other m. Then I'll have p to the 3rd power. And for right now, I'll even leave this p squared. I'm just trying to leave everything where it was. So I'm just making one change at a time. This drops down because it has a negative power. Nothing comes with it. So when it drops down, it's going to become a positive power, though. So now we've got that. So now, if there's anything we can do inside the parentheses, we should do that first before we deal with this negative power. We'll do that at the very end. So, of course, there is stuff we can do in there. So what am I talking about? What in the world am I speaking of? The 2, nothing's happening with the 2, so I'm just going to recopy that. But the m's, okay, you see the m's that we have right here? What's going to become of these m's? Yeah, that'll be m to the 3rd power, right? Okay, and let's see, what will become of these? Okay, I need a better color than this. I'll use this. What about these p's? Okay, well, there are more p's in the denominator, so these 2 p's will cancel out 2 of these p's, and that will leave 1 p in the denominator, like that. So there's nothing in the numerator, right? So we will just use our little placeholder. So this is what we have now. Now would be a good time to go ahead and do our reciprocal thing. So like we've seen before, if you have, you know, a over b to the -4 power, that's going to be the same thing as b over a to the +4 power. Okay, let that soak in. So that's what we're about to do right now. So let's do the reciprocal. If you do the reciprocal, however, okay, then this 1 would wind up on the bottom, and this 2m to the 3rd power p is going to wind up on the top. I'm just going to OCD and keep the colors the same for one more step. Okay, now I did the reciprocal, and I will have that +4 now. But do I really need this 1 down here? No, not in the denominator we don't. So I just have that. So now it's time to apply this. So question, is this going to be 8? When I do the 2 and the 4, is this going to be 8? No, it is not. Now I happen to, because what's really happening is we're doing 2 to the 4th power. And 2 to the 4th power is 16. Now according to the rule that we came up with, if we're going to go 4th power or higher, you can just leave it. But you know, 16, you could put 16 if you happen to know it. But look at the m, power raised to a power you multiply, so that'll be m to the 12th power. And then look at the p, it'll just be p to the 4th power. So that's just it, 2 to the 4th power, m to the 12th power, p to the 4th power. Alright, and that is it for this lesson. I hope it was helpful to you. Remember, if you're watching this video, you're one of the good ones.